Okay, so we're solving by completing the square. In general, this is not a method you would use to solve a polynomial equation, right? This is a method that we're going to use once as a stepping stone to get to a new place, and then we're not going to use it anymore. It'll be one question on the test. It'll be one question on the final, because I'm brutal like that. That's the way mathematicians are. Oh, almost big shot. Okay. So, again, this is not a practical method that you would use to solve a quadratic equation most of the time. However, you will specifically use it when I say specifically use this method. Okay, so just as review, right, if I have x plus 3 squared, that's x plus 3 times x plus 3, multiplying it out, I get that it's equal to x squared plus 6x plus 9. Okay? So in general, if I have x plus anything, let's call it a, okay, that's equal to x squared plus 2ax plus a squared. Okay, where this would be the coefficient here, and this would be the number there. Okay? So,
This would be x plus a squared in general.
whoop, yeah. Shoo. Yeah, otherwise that's just magic. So once we know the first and second terms of a trinomial, there is exactly only one third term that makes it a perfect square. So here's an example or two. I'll do one right here. So for example, if I had x to the third plus 8x plus blank, what would have to go there for it to be a perfect square? Same thing here, if I have x squared minus 10x plus blank, what would have to go there to make it a perfect square? And this is the first part in our process, is finding the one and only thing we can put there to make it a perfect square. Not 6. So it is 16, although not because of a times 2. Okay, and we could try this. Let's check. Okay, let's see. Adds to be 8, multiplies to be 16. That's positive 4, positive 4. So that'd be x plus 4, x plus 4. So hey, that did work. This is a perfect square. Check. Okay, 16 worked in that one. That was the one and only number. If you put any number other than 16 there, it is not a perfect square. Maybe you could factor it, but the only thing that makes it a perfect square is 16. Okay, what about for that second one? What would go there? Yeah.
How would you figure it out?
Whoa, we haven't gotten there yet.
Oh.
This is kind of a guessing game right now.
25.
25, interesting. Well, let's check if 25 works. Alright, I don't know. Okay, so let's see. Adds to be negative 10, multiplies to 25. So yeah, that'd be negative 5 and negative 5. X minus 5 times x minus 5. Hey, that's a perfect square. X minus 5 squared. Check. Okay, so how'd you figure that out, Dan?
I guessed.
Whoa, guessing. That was a really lucky guess.
Well, to get negative 10, it has to be 2 negatives.
Yeah.
I mean, because the first one,
And you said you wanted a
I
perfect
heard someone
square.
say divide by 2. And if you divide 8 by 2, you get 4. And if you multiply 4 by itself, you get 16.
Exactly. So we take that middle term because that's 2a. So if we want to find a, we do this divided by 2. And then we square it, right? So exactly what he just figured out. We take that middle term, divide it by 2 to get 4. That's what our a is. And then how do we get a squared? We square it. Okay, so here, we take that middle term, and this is 2a. So we divide it by 2, we go negative 10 divided by 2, okay? And then we square it. So that's equal to negative 5, that's our a. And then squared is positive 25. And not only did we figure out what number had to go there for it to be a perfect square, but in the process, we figured out what our a was. So down here, x plus a is x plus negative 5, or x minus 5. So we actually not only figured out what number has to go here, we also figured out what the perfect square looks like. Right? Well done, Dan. Okay.
Hard work.
Alright, so in general. Okay, so to complete the square, here are the general steps. Okay, first, make sure the lead coefficient is 1. Because our shortcuts only work if the lead coefficient is 1. Okay, our shortcut does not work if it's not 1. Alright? So, if it is not 1, divide both sides of the equation by the lead coefficient. To make it 1. Notice that over here, this was an expression. So if there was a 2 here, you couldn't do it this way because you couldn't divide by 2. Okay, but we're talking about equations. I just gave you 2 simple examples about completing the square, but in general, we're going to be doing with equations. Okay? So number 2 is, we divide the coefficient of the second term, or the middle term, by 2, then square this number. Okay, this is your third term. Okay, and then 3 is factor the trinomial into a perfect square. Okay, so we're not actually adding and doing things with equations yet. All we're doing is completing the square, like problems, well, those are on numbers, but like the 2 examples we just did. Okay? So, here's what the first problems on your homework look like. Okay, exactly like those 2, where I didn't give you any instructions, except now you've got a plan. Okay, so here is, and the instructions say, complete the square. Okay, so 2 is x squared plus 12x plus blank. Not only complete the square, but then factor it. Okay, number 4 is x squared minus 4x plus blank. Okay, and this is the first step, and then the second step will be use this to solve equations. Wait, Dan, you help me with the last one, so let's just me and you to try this now. Nick, yeah.
I'd say it's 36.
Okay, how'd you get it?
Took 12 divided by 2, which equals 6, and I squared it.
Exactly, so we start with the positive 12,
Divided by 2.
we divide by 2, becomes positive 6,
And then
square it.
at 6, and then it's 36.
Exactly. Okay, so to write it out, start with middle coefficient, divide by 2,
And then we write it out.
square. Perfect.
We have to write it out like.
Exactly.
So,
And so what is
Plus
it?
6, x plus 6, or x plus 6 squared.
X plus 6 squared, and we knew it because it's this number. Whoa, I drew it to the wrong place. It goes right there. Okay? So on the second one, I'll show you how I write it in general. I write it like this. I go -4 divided by 2 squared equals, okay? And then I simplify. Alright, so -2 divided by 2 is?
Negative
Yeah, I said -2, meant -4, yeah. And then -2 squared is?
4.
+4. And so, you put a +4 up here, and what does it factor into?
X plus 4, x minus 4, or x minus 4, x plus 4.
X minus 2 squared.
Yeah, the reason we know that is, first of all, if you put a 4 here, 4 squared, the last term would be 16. So 2 has to go here. But the reason we know it's -2 is, this was your a in the first place, right? That whatever you squared to get here, that's what goes in the parentheses. So you already have it solved. Yeah.
Why'd you put that positive 4 down there?
That's the third term, right? So we did the middle term divided by 2.
Oh, yeah,
And
that's
then
what
we
I-
square it, so
Okay,
that positive
that's
four.
what I meant, yeah, 4 up there.
Gotcha, yeah. So the +4 goes up here. And then the last step is, so it's a two-part answer. Part of the answer is complete the square, part of the answer is factor the square. Okay? Okay, let's do 2 problems where now it doesn't work out nicely. Because it's not always gonna work out nicely. Sometimes you'll have fraction. Alright, so number 8 is x squared minus x plus blank. And 12 is x squared minus 4/5 x plus blank. Okay, I'm gonna give you a second to do those yourself. So not only find the missing blank there, but also factor it. Alright, so on the first one, walk me through what we do. What do we do?
You take the middle term, so
Yeah.
negative x, and try to, and square it, or divide it by 2.
So not middle term, middle coefficient.
Coefficient, yeah.
So not negative x, but
negative 1.
-1 divided by 2 and square. Okay, so what do we get?
Negative 1/2
Mm-hmm.
squared.
Mm-hmm.
Yeah,
So yeah, just write -1/2 next to it. What's a negative times a negative?
Positive,
Positive was 1 times 1
1,
over
2.
times 2. Okay, figured. Positive 1/4. Okay. Ah, perfect. Yeah. So we get positive 1/4. Positive 1/4 goes up here, okay? And then, how do we factor it? We already have all the information we need. What did we square to get 1/4?
Oh, 2.
2 squared root.
Or, oh, we squared 1/2, negative 1/2.
Negative 1/2. And so that, since we already did that work, let's not do it again. We get negative 1/2. However, you absolutely could factor this using your x factor. What things add to be 1/4? Or add to be 1 and multiply to be 1/4. That's a hard guess and check problem. So use that. You already figured out what you had squared to make 1/4. So put it right here. Okay, so 2-part answer. 1 is find that third term. 2nd is factor. Okay, on 12. Frank, you gonna help me out with this one?
So you go negative 4/5
Yeah.
divided by 2.
Let me get a better red pen here. So negative 4/5. Just tossing pens out left and right. Whoa, I was aiming for Nick, but I missed. Okay, so negative 4/5 divided by 2, yeah?
2 squared.
Mm-hmm. How did I do that? Way back when, section 1.2, how did I do that? We should have, Frank's got this, man. So how would we do that, Frank? Language, but yeah, no, it's good to forget. And then we remember, and that flexing of the brain muscle is good for us.
So, you write it to be like negative 4/5 times 1 over 2.
Exactly.
Cross cancel,
Yeah,
be 2 and 1.
yeah,
So be negative 2/5
perfect,
squared.
perfect.
So it'll be negative 2/5 times negative 2/5,
Yeah,
which is positive 4 over 25.
bam, so there we go. 4/25, I thought you forgot, man. Flex that brain muscle, it's
Yeah.
good.
And then it's gonna be x
Mhm.
minus 4/5.
Ooh, close.
No, x minus 2/5.
Whatever it was that you squared to get this, including the sign, exactly, goes right there.
Squared.
Perfect. There we go, and again, it's a 2-part answer there. Alright, so that's the first part of the section. Complete the square. Practice completing the square, no equation, no solving. Once you've got that down, dealing with whole numbers first, which are easier, like 2 and 4, and then building up to fractions, which you follow the exact same process. The arithmetic is just a little more involved, okay? Then, and I'm gonna erase this, we're gonna make some general steps that use this in a process to solve any polynomial equation, okay? And again, this is a little cumbersome, and we don't use this as a practical solving method most of the time, but it's how we find the quadratic formula, which lets us solve every quadratic just by plugging in numbers, and boom, our equation is solved, even if you can't factor it. It's a pretty miraculous thing. So this helps us solve every problem, not just the pretty ones that can be factored. Okay, so here's, in general, general steps to solve by completing the square. So the last steps were just how to complete the square. Okay, so now we're going to use that to solve an equation. Okay, step 1. I'm gonna pick an example here to do with us here. I don't like any of these examples. Ooh, that's a good one. I like this example. Okay, let's do 28. So right next to it, here's 28. Okay, so we got 2x squared minus 4x minus 2 equals 0. And it might be a mess. There might be parentheses, there might be stuff on both sides. In general, that's not what they do here. Okay, you were waiting, that was polite. Okay, so first thing we're gonna do, the step 1 is, we're gonna move all these numbers to the other side. Plus 2, plus 2, okay? So this step 1 here gets us 2x squared minus 4x equals 2. Okay, got it. Now step 2 is the same as before. If we want to complete the square, what do we notice here that's kind of broken for us? What do we notice? We can't complete the square yet because, yes?
Do you want to, oh wait, never mind.
Why can't we complete the square yet? Remember the steps we just went over?
First coefficient is 1.
Yeah, the first coefficient isn't 1. So the second step after we move the things to their proper sides is we divide by the lead coefficient. Comma, unless it's already 1. Or I'll just say I didn't want to just have that as its own little star, like, if it's not 1, then you need to divide. It's a whole step. If the coefficient is anything but 1, you absolutely divide the entire equation right away by that number. So step 2 up here, I'll do it in blue, is I'm going to divide everything in the equation by this 2, because I absolutely have to get rid of that 2 if I'm going to complete the square. So, dividing it all by 2, I get x squared minus 2x equals 1, okay? That was step 2.
So you said divide a coefficient to everything, every time?
The lead coefficient, the coefficient x squared, because you want that lead coefficient to be 1. So if it's anything other than 1, immediately you divide everything by it, okay? Alright, step 3. Find out what number completes the square. Okay, and add this to both sides of the equation. And that's the thing people mess up the most, is they just complete the square and they're like, oh, what number goes here, like whatever, 7. And then they just write a 7 in there. You can never do that with an equation. Anytime you add a 7 to this side, you have to add it to the other side, right? Okay, 7 is not the correct number there, but just say it. Whatever you add to one side, you always add to both. So I purposely on this step leave a blank space here, because I know the goal of this is to have x squared minus 2x plus a perfect little jewel there that will complete my square, and I will add it to both sides. Okay? So, what's that number I'm adding to both sides here?
Negative 2 divided by 2.
Yeah, so I'm going to go negative 2 divided by 2. And wait, and then what would I do next, you right?
Square it.
Square it, and so I get negative 1 squared, which is
1.
positive 1, so I'm going to go plus 1 equals, so on this side I would get 2. And so this is my step 3 here, going from here to, and then I can factor it, and what would I get on the left?
X plus 1, x minus 1. Or, yeah, x. I don't know.
Right, the whole reason we did that is so it's a perfect square, so what do we
X
get?
minus 1 squared.
Exactly, x minus 1 squared, and remember, this number here will always be what goes there. Whatever you squared to get the perfect square, that's what's gonna go in that parentheses. Alright, and then after that, 4 is,
It's because it's not equal to 0, so it was, okay, I see.
yeah, and again, like I tried to say at the beginning of this chapter, this is an exception. This method is an exception that I shouldn't say it's an exception, it's actually the most absolutely general strategy, because it doesn't rely on nice numbers that factor. But again, this is not a method we're gonna use a lot. We're developing it as just a mental exercise to get to a golden super formula. Okay, and after this, we solve it just like the last section. So I'm just gonna move off to the side here so we have lots of room. How do we solve this like the last one? Right, how do we solve this like this? Somebody other than Dan knows this so well. Ruth, how do we solve this like the last section? Right, this is exactly like a problem in 9.1. Yeah,
Square root x minus 1
yeah, and
equals positive, negative, or positive minus square root of 2.
there we go, okay, so what do I get on the left?
Then you get x minus 1
Yeah,
equals positive minus square root of 2.
yeah, okay. And then our last step, since these two will not combine, we don't need to split this up. You could if you want it, okay, but since we're not gonna combine 1 and square root of 2, we don't need to split it up, then so what will we get?
Add the 1,
Yeah,
so x equals
right, the number
1.
first, or the integer first,
1
yeah. You don't need a positive,
or
but yeah,
positive 1, and then plus minus 2.
there you go. And so that's how, from start to finish, you solve the problem by completing the square. So there's a lot to this problem, right? It uses a lot of your having to be comfortable with polynomials, right? Moving around polynomial terms, dividing by a lead coefficient, finding that perfect square, factoring the perfect square, and then solving just like in 9.1, right? So there's a lot to these problems. Okay, I'm gonna do probably 2 more examples with you that include all of this. Okay. Maybe 2 or 3. I have an interesting side note. Let's just talk one interesting side note really quick. I've had people ask me this, and I wondered this. So this is totally a little caveat. I don't want to distract. I'll save the caveat for later. We need some immediate practice with this. Okay, so let's do problem 14. 14, they were kind enough to start us off partially complete, right? Not only do we have the x squared and x is already on the left, but we also already have a lead coefficient of 1. Step 1 is done, step 2 is done. Woo, awesome. What's the next step here? Yeah.
Would you add 8 to make it all equal to 0?
We would not. That would be more general from chapter 6. If I see an x squared, absolutely. That is how we're gonna solve things in general. In this section, no. In general, anytime you see an x squared, you're right. All to one side equals 0. Try and factor it. If we can't factor it, golden super formula we're learning on Monday. Okay? But
So
in this section, it's different.
instead, you would take this second coefficient
Yeah?
and divide it by 2.
Yeah?
So that's 3.
Yeah?
And so it's X squared plus 3.
So you forgot one operation, you divide it by 2, and then,
Squared? Oh,
Squared.
yeah, squared, so it's 9.
so it's 9. And so when I wrote the original equation here, I'm always gonna leave a little space here. And I'm gonna say my equals 8 has a little room before it, because I know, what am I gonna write, Jeremy?
Plus minus thing.
Ooh, not
Or,
this
oh, okay, a 1.
We just did this whole search to find a number. What do we do with that number?
I have no idea.
Okay, so
You add 9 on both sides.
both sides, exactly. So we want to complete this square. We got x squared plus some number x's plus something. And we searched for that something. We sought it out and we figured out that one thing that completes this square is 9. And on the other side, we don't care. It's just a sloppy mess, okay? So plus 9, got it, whatever. Who cares on that side? So on the left, what have we gotten?
X plus 3.
Exactly. That's why we got this 3 in the middle here that we squared to get 9. Goes right there. Perfect. Okay. Well, that's the new part. That's the 9.2 part. And then after that, yeah, then we just solve it like 9.1, right? So how do we solve this? What do we do next?
X plus 3. Square.
Yeah, got that?
Um,
You keep saying squared, I think you mean something else.
yeah, square root.
Square root,
Yeah.
both sides, and
Plus and minus.
plus or minus, there we go. So yeah, as you said, square root both this side, and we just get x plus 3. This side, we get plus or minus 1. Okay, so how do we solve x plus 3 equals plus or minus 1? I'll write it up here just so it's high.
It's minus 3. And minus 3.
We could minus 3, but I would say we're maybe playing a dangerous game here if we just minus 3. Plus or minus 1 minus 3. So I mean, it's correct, but I would say people might make mistakes right here.
Because we have to get 2 answers, right?
Yeah, we do need 2 answers.
So
I would start by saying x plus 3 is 1, or x plus 3 is negative 1. And then we do subtract the 3. And this was right, it's just, you need to think of it as 2 different cases. It's positive 1 minus 3, or negative 1 minus 3, and people too often somehow smash it together to get like a plus or minus 2, or plus or minus negative 2, or, you know, not quite sure what happens there. So this is x equals negative 2, and this one, when you subtract 3, they collect and become more negative, so negative 4, and these two numbers are now totally different, okay? It's not plus or minus something after this. So that's why I would always split it in 2. Okay, another one, similar, but maybe building in difficulty just a little bit. Alright, let's look at 18 here. So 18, really similar, x squared minus 4x equals negative 2. And I purposely left some room there because I know what comes next.
Alright, so maybe 4 divided by 2.
Yeah. Yeah. So this is negative 4 divided by 2 squared, yeah. Negative 2 squared is
Which is 4.
4, yeah, and then,
Plus, add 4, plus 4, and plus 4.
and on the other side, 9. So what do we have?
squared. X negative 2. X minus 2.
X
X
minus
negative
2
1.
Oh yeah.
Squared
squared.
equals 2.
There we go. Boom. Okay. And then we solve it like normal, right? What do we do to solve it?
Can I help you?
Shh, you just help with the last one. You're getting greedy, but I
So-
appreciate the enthusiasm. Yeah, Nick.
So, take the x
Nick's been
minus,
sitting there. He's been anxious.
x minus 2 squared and the square root around it. And then same thing on the other side, we could add the plus and minus.
There we go. So what do we get?
X minus 2 equals plus or minus square root 2.
There we go.
And then, since it's a square root, we can't combine them, it's only
Okay.
one answer.
Exactly.
So add 2, both sides. So this would be x equals plus or x equals 2 plus or minus square root 2.
Exactly. So something you said there, which isn't 100% correct, but is the right idea. We're gonna write it in one way, but it still represents two separate answers.
Yeah, but it's only because you can't combine them.
Exactly, yeah. But it still does fully represent, one answer is 2 plus root 2, one answer is 2 minus root 2, so it'd be okay to write it like that, wouldn't be wrong, but you're right, I mean, that's the simplest way to write it. Be careful that you don't think that that's one answer. That is two different answers. If you plug this into a calculator, this is like 3.4, and this is like 0.4. Two totally separate correct answers that I could plug in, so just a little careful, but yeah, perfect, that's it. So big idea is, once you have a lead coefficient and all the x's on one side, you just complete the square, looks like this, square root both sides with the plus or minus, and then one step to just add or subtract it over, okay? But it could be harder. I bet you guys didn't guess that, right? We're only on number 18. Oh, there's so many more numbers after 18. How high can we count? Okay, so let's look at 24. 24 is a little harder because there's a fraction and a step before we get started. Okay. So what should we do first? Anybody get help here? I love the teamwork.
Add 5 plus 5.
Yeah, I would get rid of that first, just because otherwise what you have to do is when you figure out I need a 4 here, you'd have to say, what do I need to do to a 5 to get a 4? And that's a little harder than just putting a 4 there, right? So if it's a blank space, it's a lot easier than what do I need to add to get what I want? Okay, so yeah, we add that, we get
X squared minus 3x equals 0. Or equals 5.
and again, I'll leave a blank space there.
So
Okay.
take the second term
Yeah.
and multiply or divide it by 2.
Okay,
And square.
and square.
So it's like 1/2. Negative 1/2 squared.
Where did 1 come from?
Negative 3 divided by 2.
So negative 3 over.
Oh, no, oh, yeah.
Yeah. Okay, yeah. It's okay, it's self-learning, it's the first time we've done this stuff, you guys.
And then so it's 9 over 4.
Perfect, it's a positive, it's negative times negative, so
9 over 4 plus 5, or that's plus 9 over 4
yeah,
on both sides.
yeah, exactly, on both sides. And so what do we have?
Negative 3 over 2 squared. No, wait, so,
Right number, but what do we actually have? Completely.
X.
oh, no, yeah, negative 3 over 2.
But we'll start with
X.
x,
Oh,
Minus.
minus 3 over 2.
there we go.
Squared.
Perfect, equals, and then we gotta do just a little arithmetic. This is over 1 times 4 times 4, that's 20 over 4 plus 9 over 4, so 29 over 4, okay? And then?
And then, just do the roots, be, yeah, plus minus.
And a plus or minus, yeah?
So that would be, x minus 3 over 2,
Yeah,
plus minus, no wait, you got
Okay.
to factor those two out, right?
well, let's write it first as plus or minus 29 over 4, but you're right, the bottom, on all of the problems we do together, the bottom will always work out to be a nice integer. So you can split this up to be plus or minus root 29 over root 4, or plus or minus root 29 over 2. And on every problem we do, the bottom, the denominator will work out to be a nice integer. So just to rewrite this, x minus, yeah,
Plus minus, root 29 over 2.
okay, and then?
Minus, I mean, you add the 3 over 2 both sides.
Exactly, and since we can't combine it, we can do that. It's one equation, and what we got?
X equals plus minus, X equals 3/2 plus minus square root 29/2.
There we go, and it's 100% correct, but we could write it in a little different way. 100% correct, full credit. But you could write it as
Three square root, or 3 times square root of 29.
times,
Plus minus
Over
square root
two.
29.
yeah,
Over 2. Oh, all of that over 2.
all of that over 2. Since they already have a common denominator,
Oh.
either of these is 100% correct, but this, right here, this is your first view, your first peek at what all general answers to quadratics look like, in general. This is that negative b plus or minus square root of b squared minus 4ac all over 2a. That's that formula that we learned, and that's how all the general answers are gonna look. When you can't factor a quadratic, all of the answers look like this. Number plus or minus square root over number. Okay, so in general. All right. One last example. To be a little crazy. We put everything together into this one. All right, this has got everything. So 3x squared minus 2x minus 4 equals 0. The one thing they could have added, but they're not cruel, is they could have added some parentheses, some like terms. They could have put some sloppy on stuff on the other side. So you might have to clean it up a bit. But this is what it would look like after you cleaned it up. Okay?
Plus 4. Both
So,
sides.
yeah, so plus 4 to both sides, so we got just what we want over here.
3x squared minus 2x equals 4.
Yeah, and I leave some space. Yeah, okay.
Then second term,
No, you delete coefficient, you divide.
delete
by
coefficient,
Yeah.
yeah.
Of
sure.
Always need that lead coefficient you want. Good catch. Right? So divide everything by 3. And now you can see why this problem's going to be a little messy compared to the other ones. X squared minus 2/3 x equals 4/3. Don't worry, everything's going to work out to a nice number on bottom and an ugly square root on top. We already know that. Okay, so now what do we do?
Second term,
Yeah, so
Divided by
negative 2/3 divided by 2 is squared. How would we do that?
multiply the inverse,
Yeah, so
so negative 2/3 multiplied by 1/2,
there we go. So
cross cancel.
we get negative 1/3 squared, which is
1 over 6. Negative 1.
1/9.
9.
One.
Yeah. It's okay. So then what do we do over here? And it's not a speed race, it's about quality here. So what do we do over here then? Once we found that perfect square,
B.
1/9.
yeah, and
And on the other side as well.
there we go. And so what do we have now?
X minus 1/9 squared, 1/3 squared.
Yeah, whatever we squared, that's what comes over here. So minus 1/3 squared equals, and let's just do a little arithmetic, times 3, that's 12/9 plus 1/9, so that's 13/9. And you can see when we take the square root, that bottom will work out to be a nice square root, top one. Okay. So I'm just gonna bring it over here to continue. What's the next step?
Square them out. Root them out,
Yeah. And
plus minus.
plus or minus. Okay, so up here, we have x minus 1/3 equals plus or minus square root of 13/9. And as I was saying, the bottom will always work out nicely. So this is plus or minus square root of 13 over square root of 9, or plus or minus square root of 13 over 3. So I have x minus 1/3 equals plus or minus root 13 over 3.
We add 1/3 both sides.
We get x equals,
1/3 plus minus, square root of 13 over 3.
yeah, which is 100% finished and correct,
Which
but we
is
could
X
write.
equals 1 plus the square root of 13 over 3.
My
plus minus.
Yeah, plus or minus, we gotta, I just wrote plus, maybe you said plus or minus. But so, that's the general format of our answers. And after we take the square root, that bottom will always work out to be nice and even, nice integer. Okay, good quality problems. So just a little side note, take a couple minutes here, just to mention why, this is a good question. Why do we only put the plus or minus on the right? I mean, if I've got x squared equals 4, why do I arbitrarily go square root is, well, plus or minus 4, but what about plus or minus x? Why don't we do that?
Because your answer is gonna be after the equal sign.
No, I mean, the answer is, some x equals.
Is that because we gotta get, because we gotta get two answers, like a positive and a negative?
Yeah,
You can't do a positive negative x squared, right?
you can. Well, let's try it out, let's see what happens. Okay, let's say we did do plus or minus x equals plus or minus 2. What are all the possibilities there?
-1 x equals 2, and
Negative x
equals
equals -2. X equals 2, x equals -2. 40
So, let's see, what if we had negative x equals 2,
Do it by the before.
and what do we get?
X equals -2.
Oh, so we already have that one, so we don't need it. Okay, what about this one?
Divide by 1. Divide by 1. Already have it.
Oh, that's x equals 2, we already have that one, so that whole negative x is just redundant. So actually you are saying positive or minus this side is equal to positive or minus this side, but the only real circumstances you have is either they're the same sign or they're opposite signs. So in other words, it's either positive or negative. So really, that's why we only put it on the right side. We do put it on both sides. Everything is positive or negative, but the combinations would just be redundant. You'd be solving 4 equations to get the same 2 answers every time.
Because the equal sign equals multiply, right? Like that as it looks right there, so you could just like cross cancel it.
Kind of, more like division. But yeah,
Right?
yeah, but the idea being, if they're the same sign, the thing you would divide by would be that positive 1 or that positive 2 or that positive 4 or whatever, and so the signs would be the same. Whereas if they're opposite signs, the thing you divide by is a
Or if
negative.
you just put it on one side, you just put it on the x side, not the 2 sides.
For sure.
And
You just do negative plus or minus x equals 2.
Yeah.
So either positive x equals 2 or negative x equals 2, which would be x equals -2. So yeah, this is the same thing as this, right? One is solved and one still needs solving, but yeah, exactly the same. So you only need it on one side because putting it on both sides would just be redundant, the number of them. Alright, I thought it's like that. I was like asking why. Right? We follow the same steps always, but sometimes there's shortcuts and we leave things out. You can always ask why. Alright,
So is it all the problems in 9.2?
that's it. That's all the problems in 9.2. The worst thing you're gonna see are some fractions.
There's a test on Tuesday? and
Test on
over
Tuesday.
to Monday?
Yeah, so if you don't get to finish 9.2, because in the morning class, we didn't get to finish 9.2 all the way. Well, we did finish, but it was kind of a little of a scuttle, a little rush at the end. So I told them their 9.2 isn't due till Wednesday. So why don't you just save your 9.2 problems, turn it in on Wednesday, but do them. I mean, do them as soon as possible.
What's the test gonna be on?
Everything. So 8 and 9. So 8.1, 3.3.
On Tuesday?
9.1, 9.3. Yeah.
Nice.
But the nice thing is, the only new thing on Monday that we're learning, as usual, every time we've had a test so far, we've gone right up to the day before to one section and then review. And so that one section we're doing on Tuesday, or on Monday, is just, and you can look forward, it's literally the formula, x equals -b plus or minus square root b squared minus 4ac all over 2a. And so the way you solve any polynomial equation or quadratic is you move everything to one side. So you have some number of x squareds plus some number of x's plus some number equals 0. And then you plug in a, b, and c into this equation and get an answer. So that's why I think 9.3 is a really easy section. So we're gonna do that on
Do we
Monday.
have to remember that formula, or is it?
I'll
I'm
say,
gonna get all those
I'll
formulas
say-
tattooed like on my forehead. I can't take them off.
I'll just make you wear sleeves. No, no, I mean, I would say, yes, you should know that formula, but no, I always write the formulas on the
Okay,
test
cool.
if you need them, yeah. But that's it, so that's 9.3 on Mondays. We're just gonna use that formula and over and over and over and over, you're gonna plug in A, B, and C and get answers. Yeah, that's it.
Thank you.
All right.
No problem.
All right, thank you.
Yeah, no problem. Have a good rest of the day, you
All
guys.
right, you too. Enjoy the weekend.
All right, you too.
All right.
Gonna be an awesome weekend.
This is like the only class I ever sat in for that much time.
Good. So probably the single most important math class you'll ever take, and if you go on to any other math classes.
Yeah, I'm going on.
Yeah.
Second time I've taken this. This will be the second time.
Yeah, but it's
But this is
crazy.
the first good teacher I've